Okay, one part of trig. Figuring out the ambiguous situation and how do we know. So ambiguous is when there's a triangle with a side and an angle in an order like that. Okay, so how many are formed? So I'm going to draw myself an unknown side, and then I'm going to put angle A at 36 degrees. Which side would I draw beside A? The 15A side or the 12B side? Which one would go beside it? B. Because where should A go? Where's A from A? Across, right? Not beside. It has to be across. Okay. Ready? What do you know about A of 15? What's the rule? The longer, shorter stuff, what do you know? It is longer. It's longer. So now what? How many triangles? Boom. Answer 1. As soon as it's longer, there's only one possibility. If you forget, here's some visuals. Think about 12 being like that long. 15 would be a little bit longer, right? Where? Where does 15 kind of reach? Only one spot, like way over there. That's it. Okay. Same idea. I don't know, but I know A is 40 degrees. What is beside that angle, the 8 or the 10? The 10? So 8 is opposite across. What do you know about 8 compared to 10? It is shorter. So I don't have an answer for you. With one or with longer, it's just boom, it's 1. But if it's shorter, you got to figure it out. So what we're going to do is we're going to say, well, what is the height of this thing now? So can you figure out the height? So I'm going to go like this. 10 over sine of 90 degrees. Do you see that set? 10 is across the 90-degree corner. And the height is across a 40-degree corner. .43 was my number. So how does 8 fit into that? So we said it was shorter than 10, but now it's longer than that one. So can we say it's between? So what happens if you're between? What happens if you're between? There's going to be 2 triangles. Can you visualize 8? If this is 10, 8, so if this is 10 and this is 6.4, then 8 is like that. So how can 8 travel? It's going to go between. Okay? Does that make sense? Can you visually see it? Okay, next one. So I don't know a side 29 degrees, 6 or 15 beside it. Okay, so there's the locations. A is across and 15 is beside. What do you see with 6 compared to 15? Shorter, longer, what? Shorter, so we don't have an answer. So that means I'm going to have to figure out the height. I got 7.27. So how would 6 fit into all that? Where would 6 be in comparison to that? Would you agree that 6 just wouldn't even ever touch? So it ended up being shorter than the height itself. And if you're shorter than the height, you're never going to touch. Okay, next one, I need you to pay attention because when I'm drawing this one, this is a little bit unique. There's a 130-degree angle when I draw it. So think about how 130 degrees looks. So I don't know a side. I always start like that. I don't know the side, but there's 130 degrees. For angle A. What is beside the A? 21. And across the A is 16. I can already tell you the answer to this. How many triangles would this make? And the answer is it's not even possible. There's going to be no triangles, but you now have to tell me why. That's your answer. There's no triangles possible at that. Why? Give me a reason. Do you see something? What do you know? 130 degrees would have to be what? Would you agree that no matter what, it's the biggest angle in any triangle? You can't be bigger than 130 inside a triangle, right? So what has to be across from it? If this is the biggest angle, that has to be the biggest side. So is it possible? No, because that one was 21, so you can't have that. Do you know if you would have done this work if I would have done this kind of work on my calculator, this across from this across from this, times, divide, inverse, what do you think my calculator would have done probably? Would have given me an error signal. It would have said that on my calculator screen. Okay, and that's why. Okay, solving an ambiguous triangle. So let's go. Don't know that side. Draw me a 33-degree. What do you want to put beside it? The 10 or the 12? Okay, solve for both possible triangles. So I'm already telling you, you don't have to do the work. There's two triangles. Okay, so can you think about 10? How do you pivot 10? Where would it make a triangle? So I might even do this. 12, so 10 could pivot here. Or if I keep pivoting, it could have been over like there. You see it? Pivot 10 could hit, or hit. Anybody need my highlighters? Because I need you to understand the two triangles. It's probably easier if you visually see it with color. And on the test, he's asking you to use some color on paper. Pass them around to everybody else over in the corner. Need some. So here's the goal. My goal is to say for this yellow triangle we have 12, 10, and what? And then in the pink triangle, 12, 10, and what? That's the goal. Okay, so this is how we start. A pair. So I'm going to go 10 and 33. That's a pair. 10 and 33 are across from each other, and then 12 is across from what angle? So you should know this, across from 12, there's two options. So you're going to have to say this or that. There's going to be two options of angles. So your calculator is only going to tell you one of them. Times divide inverse. Who remembers how to get the other one? That's the calculator's one, but you have to understand what the other one would be. Supplementary, whatever is the supplementary option. Okay, looks like some of you are going to have to make sure you remember that. So now, can you place those in the diagram? Across from the B, there's one across from the B, or there's two across from the B. Look in your yellow across the B, the pink across from the B. One of them is bigger than 90 and one of them is smaller than 90, so you're going to have to figure out which one's what. Okay, did you think of them in the same spot as me? One that's small, one that's big. Okay, so what do you want to do? Dial into the yellow. Okay, we got a yellow angle, yellow angle. Get me the last yellow angle. 7.8 at the top of that one. That was good. Okay, I'm going to figure out the yellow side at the bottom then. So I'm going to go 10 and 33 degrees are partnered. I'm going to call this C1 across from 7.8 degrees. Or 2.49. Okay, now I'm into my pink triangle. So what's the top pink angle? So here's a corner with 33 and there's a corner with 40.8 in the pink triangle. So then what's the top corner? 106.2. So you will have a question exactly like that on your test. Obviously my numbers are different. I'm expecting you to draw that and have all your components. I'm going to show you somebody who did this wrong. Somebody did this. Why did they get it wrong? Just their drawing. What's wrong with that drawing? So across from the 12 is angle. Across from the 12 is that angle. What's wrong with the situation now? What do these angles always have? One is always smaller than 90 and one is always bigger than 90. Always. So then, what's wrong with their drawing? They have two things below 90. Can those numbers be supplementary? If they're both under 90, can they add to 180? No. Does that make sense? Okay, word problems. Yeah. How did I get 106? Was I wrong? So I did 180 minus this corner and this corner. Do you see my pink corners? These are my pink corners. Is it different? Did I do it wrong? Or did you find something else? Minus 33. Yep, I got 106.2. Can you visualize the pink corners? Okay, Pearl was walking to her friend's house, which was 2 miles straight east. Pearl to her friend's house, straight east. I'm doing little compasses, by the way. That's those little T's are my compasses. Unfortunately, Pearl left in the wrong direction. Instead of just going east, she took off heading south 10 degrees east. So here's Pearl. How can you draw her direction? South 10 degrees east. Can you give me a line that shows me south 10 east? Okay, how is our direction there? South, right? South and then 10 onto the east side. That's good. Okay. And she only noticed she was off course after she had walked a whole mile. So 1 mile noticed. Now, how far and in what direction will she need to go to get to her friend's house? Okay. There's another angle I should write on my paper. Do you see an angle? Quickly, something. A noticeable angle. Anybody see one angle that's jumping out of the page? I need that number and I know it. How do I know it? This corner should be 90 altogether, so this should be 80. Do we have one of our things, our strategies? Do you know all of your components? Do you have pair, SAS, triple S? That's always your triangle stuff. You got 3 things, 3 major things. Do you have one of those major things? Yeah, I have SAS. So x squared equals 2 squared plus 1 squared minus 2 times 1 times cos 80. Okay, again, you get these formulas on your formula sheet, but you have to know how to use them. Square root answer. .07 was my answer on that one. No?
I pressed the wrong button.
Okay, that's how far, that was the question. What direction is she going to have to travel? So I would like to know what's going on with the angle in this corner now. Okay, I want to know this angle down here. So would you be okay if I set up a sine law stuff right here now? Do you see it now? Now that you have that, you can go sine law. So 2.07 is across from the 80 degree, and 2 miles is across from what angle in that corner? Times divide inverse. But that's not my answer to the question. We're going to have to do a bunch of stuff yet. Okay, I'm going to zoom in to this corner. Okay, if this stuff was at the top corner and now I'm here, can you use your alternating interior properties to flip the 80 to that side as well? Then this is 72.1, and then that's the direction I'm going. Do you see that? 72.1 is in the triangle, but it's not a direction. So, what do you want to do now? So if I add that, that's 152.1. But really, what do I want to know? How much do I have to tell them to go past the north? How much do I have to tell them to go past the north? Can you figure that out with problem-solving skills? How much past the north are you going to be? I'm going to leave it for you. You're going to do a little problem-solving. So my answer would be north 62.1 degrees towards the easterly side. That would be my direction part. Okay, that's probably the hardest part of that word problem stuff. Okay, so the surveyor question on your test, we did one yesterday. A surveyor places measurement devices along the north and the south side, so those are A and B. He knew the distance between the devices was 1,400. The surveyor uses these devices to determine the width from the west to the east side across the lake. So that's our goal, is to get that distance. From device A on the north, the angle between the west and east ends, so the angle is 86 degrees. I'm just going to put it at the top like that. That angle, that whole angle is 86. From device B, the angle between the ends is 110. So from B, that angle is 110. Go back to device A. From device A, the angle between B and the east is 18. Where do you put 18? So you are at the A corner, and you're looking from B to the east, and it's 18. When you pivot your head from B to the east, it's 18. Did you put it there? So remember, from A, so you're at A, and when your eyes change from B to the end, that's 18. So as I look from B to the end, that was 18. From device B, when you look between A and the east, that is 79. So where are you going to put 79? Right there. How wide is the lake? Okay, so now here's what we're going to do. Can you get me this angle, this angle, this angle, this angle? You got a bunch of angles. You could go, if the whole thing was 86, what's the other side here? If that whole top was 86, then there's a 68, okay? You finish out all the angles. Are we good with our numbers? I got a 68 beside the 18. I got a 31 beside the 79. And then I also completed the triangles over here, 81 and 83. Good? Okay, I need you to split apart. We're going to split left and right. This is the exact same test question again. So kind of get the strategy down. You want to split left and right. Now, I need you to commit to something at this point. What do you want to do? Do you want to commit to going top tops? Or do you want to do bottom bottoms? You have to pick either top top or bottom bottom, not one top and one bottom. Anybody have a one that they prefer? Okay, I'm just going to pick then. Let's go with the top. We're going to go to the tops. Okay, so I need you to get me those side lengths. So you're going to have to do two scenarios. So this is pair stuff. So 1400 over sine 81 equals, I'm going to call it x over sine 31. Okay, so part of the strategy was to split left side, right side, and then we're gonna just do top. That was the goal. So now I need you to focus in on the triangle, just the top. So we got all those sides on the top. That was our top. What's the angle at the top? We have that. Did you write 86 in the top there? We wrote that on the diagram. And there we go. We're ready to find the whole thing across the lake. What do you see there? Pairs, SAS, triple S? See something? I see a SAS. So this squared plus this squared minus 2. Oh, lots of writing. $15, $19, $56? No. Getting those eyes that it didn't work out. Okay, so I know these questions on the test are kind of hard, but again, just reps over and over again and making you do the same process. So make sure you just practice so you get that process down. Left triangle, right triangle, top triangle. There's just a bunch of different steps. Hunter, did it come out that time? Okay, a person is on the ground and they're trying to determine the height of the building. What kind of question is this? The one where we went outside and measured the flagpole. So do you remember the drawing of the situation? We're going to figure out the height of a building. And we are somewhere on the ground. And then remember, Sean looked up at an angle. So from where the person is standing, the angle of elevation is 38 degrees. And then what did we do? Fabi and Hunter, they held that tape measure on the ground, right? And then we went 46 feet away. And then Sean and Carlin were looking at the angle again to be 31 degrees. So how tall is the building? Okay, you need to write in angles. Anywhere you can find angles. You got supplementary stuff, you got 180 triangle stuff. Also your 90-degree corner. Can you get me every angle you possibly can think of using supplementary lines and 180 triangles? Okay, I can put angles in any corner that I can see. So my first one was that on the ground, the whole ground should have been 180 right there, and then the whole triangle over there, 180. Okay, what's the situation we did? We had a pair set up, and then we did this. Why didn't I pair this yellow with that whole thing? Why can't I go this and this? This and this is not allowed because it's two different triangles, right? There's technically 3 triangles in that drawing, so you can't pick one triangle and a different triangle. So we have to find that middle side first, and I'm going to call it Y, something different. Times divide. So I got 194.4. Now I'm done with that triangle, so I cover it up. I'm done with that, and then I move to the other triangle, which would look like this now. I'm visualizing just this separately. Okay, also on the test. So again, harder word problems, but we've done the process, so it's kind of remember what you're doing. Okay, we have one more question to go, and then that's it, and you've learned and repeated all the hard questions of the unit. I'm picking out the hardest ones. Okay, a flight goes northeast. So here's what we're going to do. I need you to kind of put the start there. And we're going to head north 43 east. Where can you flip-flop 43? On my drawing, where could you flip-flop 43? You could also flip-flop 43 to that in alternating interior. Okay, so it stops at town A, and that was 312.4 kilometers. Then it goes from A, and it heads south 73 east. So from A, can you draw me a path? South 37 east. And then I get to town B. And I'm just going to tell you this. Town B is lower than the start. So I'm going to draw it a little bit lower. It's hard to kind of know, but I know the answer, so I'm just going to tell you to draw it a little bit south. This is Gretna, lower than Winkler or something, right? Can you flip-flop 37? Any other place? Flip-flop 37. If a pilot was to go just from start to B, so I want this pilot to go, boom, just that path. How far and in what direction? If you could go just start straight to B with no stopping. Okay, so let's start with the distance. I see SAS. I see SAS. What is that angle up there? Getting 80 degrees. Sorry, it's going to be a big type. All that square root answer. Good with that number? 468.94. Okay, 2 more minutes. We got to get this angle stuff and then we're done. Okay, I need this angle in this corner of my triangle. So I'm going to be working with 468.49 is across from the 80 degree. And 408.16 is across from that corner. $59? Anybody? $59, good. Okay, so 59 degrees is that corner. So this is more than 90. So that's why I know I'm lower. I'm going south because this is more than 90. 43 and 59 make more than 90, so that means I'm going a little bit south. So can you get me my compass? So what am I heading as a path? I'm south. I'm closer to heading south than north. South, what? So there was 43 degrees outside the triangle, and then in the triangle there was 59, so then outside on here would be 78. How did I get that? Just 180 minus, there's those three all together make 180. So now you can see I'm closer to this south than the north, and I'm pivoting to the east.